Okay, so in this series of videos, I want to go ahead and talk about the derivatives of trig functions. Um, so first off, just kind of what is it that you're expected to know from pre-calculus and algebra 2 and geometry and all the different places you may have seen trig. You are expected to know how to write any trig ratio in terms of sine and cosine. So tangent is sine over cosine. Secant is 1 over cosine. Cosecant is 1 over sine. Cotangent's the one that can be a little tricky. We do not want to think of cotangent as 1 over tangent. And the reason for that is tangent is a discontinuous function. Uh, Anywhere that cosine is 0, tangent doesn't exist. And if I think of cotangent as the reciprocal of that, I'm keeping the discontinuities from tangent and introducing new discontinuities. Uh, Whereas cotangent is discontinuous, but just in different places than tangent. So we want to think of cotangent as cosine over sine. Then you are expected to know your common trig ratios, including if you have to use reference angles. Angles will always be in radians. And then the Pythagorean identity is just really helpful. Sine squared plus cosine squared equals 1. And I can translate this by dividing everything by sine squared into 1 plus cotangent squared equals cosecant squared. Or if I divide everything by cosine squared, I get tangent squared plus 1 equals secant squared. It's a nice, just useful kind of catch-all identity for us. In terms of what we're doing, the two most important trig derivatives are the derivative of sine and the derivative of cosine. And this is because any other trig ratio we can write in terms of sine and cosine and then use the quotient rule to evaluate it. When we are face-to-face, I will talk more about why is the derivative of sine equal to cosine and why is the derivative of cosine equal to negative sine. Those are just kind of difficult to talk through in a video. But for now, I have a feeling that everybody's okay with kind of taking on faith for the moment until we discuss this in person, that the derivative of sine is cosine, the derivative of cosine is negative sine. I did want to go ahead and demonstrate for you how we would find the derivative of other trig functions if needed. So if I wanted to find the derivative of tangent, well, tangent is sine of x over cosine of x. So if I want the derivative of tangent of x, I'm doing the derivative of sine over cosine. So please note, sine and cosine are functions themselves. I'm dividing them. This means I need to do quotient rule. So I'm doing bottom times the derivative of top minus the top times the derivative of the bottom all over the bottom squared. So now to do some simplifying, cosine times cosine is cosine squared. Negative sine of x times negative sine of x is positive sine squared. And this is all over cosine squared. Well, cosine squared plus sine squared is the Pythagorean identity. So this is 1 over cosine squared. But that's the same as all of 1 over cosine of x being squared. And that is secant squared. And so here, the derivative of tangent of x is secant squared of x. Now in reality, most people just memorize the derivatives of our 6 trig functions. And I'll be honest, I would pretty much recommend that because while it's annoying to have to memorize things, it's faster than always going through the derivation of the derivatives each and every time. So derivative of sine is cosine, derivative of cosine is negative sine, derivative of tangent is secant squared. Derivative of cosecant is negative cosecant cotangent. Derivative of secant is secant tangent, and derivative of cotangent is negative cosecant squared. Now there are some patterns to help you memorize those, because just read out like a list like that, it's kind of hard to imagine that that's easy to memorize. It's really not that bad. First of all, please note which derivatives have negatives. Cosine, cosecant, cotangent. All of the cos have a negative in their derivative. Other thing to note, if I look at the derivative of secant versus the derivative of cosecant, cosecant has the negative because of the co, but then notice secant x versus cosecant x, tangent x versus cotangent x. I have a negative sign, and then I'm just sticking co with each part. So if I know the derivative of secant is secant x tangent x, I throw a negative and make each of these a co to get the derivative of cosecant of x. Similarly, notice the derivative of tangent is secant squared. Derivative of cotangent is negative cosecant squared. So it still follows the same pattern.